Assalamualaikum and hi. Today we will continue our lesson to subtopic 4.2 specific heat capacity. Alright, we will discuss the formative practice 4.2 in your textbook, page 136. Alright, first question. What is the difference between heat capacity and specific heat capacity? Alright, now if we look at the terms heat capacity and specific heat capacity, we can see that there is difference in the terms itself. Okay, now, so let's see the differences. Alright, if we look at the answer given, okay, provided for you, okay, we can see that the heat capacity, alright, its symbol is C, right? Compare with specific heat capacity, its symbol is small letter C. Alright, how do we define between these two? Alright, to make it easier for you to remember and differentiate between heat capacity and specific heat capacity, okay, I suggest you to refer to its equation. Alright, heat energy for heat capacity is heat capacity times by theta, when theta is the change in temperature. Thus, we rearrange again the equation. So the the heat capacity equal to energy, okay, Q over change in temperature. Thus, we will define the heat capacity as heat energy requires to raise the temperature of an entire body by 1 degree Celsius. Okay, by 1 degree Celsius. Okay, next, how do we define the specific heat capacity? Alright, now we refer to the equation of the specific heat capacity. Alright, so we rearrange the equation and specific heat capacity equal to Q over M theta. So we define the specific heat capacity as heat energy requires to raise the temperature of 1 kilogram mass of the body by 1 degree Celsius. Okay, now, how do we remember, okay, how do we determine the SI unit for heat capacity and specific heat capacity? Okay, same as how we define the heat capacity and specific heat capacity, we refer to the equation. So when we refer to the equation, Q, which is the energy, heat energy, unit in joule, over theta, which is change in temperature, so over degree Celsius. So the unit for heat capacity is joule per degree Celsius. Now, let's determine the specific heat capacity for, let's determine the SI unit for specific heat capacity, alright, through its equation. So, heat energy, its unit is in joule, okay, per mass in kilogram, and also degree Celsius. So the unit for specific heat capacity is joule per per kilogram per degree Celsius. Okay, now let's continue to second question. How much energy is needed to increase the temperature of 0.2 kilogram mass of gold by 10 degrees Celsius? Alright, now the unit for mass is in kilogram, the unit for the temperature is in Celsius, and it is given the value of specific heat capacity of gold, which is 300 joule per kilogram per degree Celsius. Now, for this question, we apply the equation, okay, the equation of specific heat capacity, since it includes the value of specific heat capacity. Okay, now, okay, the heat energy is Q equal to MC theta. So we substitute the value of mass, specific heat capacity, and change of temperature. So we can cancel off the unit of degree Celsius with per degree Celsius, per kilogram with kilogram. So what left is the unit of joule, which is the unit for heat energy, 0.2 times 300. Alright, now question 3. A container contains 200 grams of water at initial temperature of 30 degrees Celsius. Alright, so we can see that the unit is not an SI unit. So the first thing to do is to substitute this unit to kilogram. An iron nail of mass 200 grams at temperature of 50 degrees Celsius is immersed in the water. So we have two objects. Okay, so to say, okay, we have two objects. The first one is water, and then the second one is iron nail. Alright. Okay, what is the final temperature? What is the final water temperature? State the assumption you need to make in your conclusion. Alright, final temperature of the water is when the system, alright, the iron nail and the water had achieved the thermal equilibrium. Alright, from our previous exercise, we learned that during the thermal equilibrium, the two objects are in contact and they have same temperature. Okay, they have same temperature when there is no heat transfer. Right, no heat transfer. And the final temperature, okay, is during the thermal equilibrium. Alright, now, okay, the final temperature of both mass means both objects had achieved the heat equilibrium. Eventually, there we have the same temperature. Okay, now, when they have the same temperature, the heat energy, okay, of water is equal to heat energy of the iron nail. Alright, from the equation Q equal to MC theta, so M for water, C for water, and theta for water, same goes to heat energy for iron nail. So Q equal to MC theta, M mass for iron, C for iron, and theta change in temperature for iron. So we substitute the unit, okay, 0.2 Okay, specific heat capacity for water is 4,200, and then the change in temperature. Okay, for the change in temperature, these are our assumption. Okay, our assumption is the water which is 30 degrees Celsius will increase its temperature. Okay, so 30 degrees Celsius is the smaller magnitude of temperature compared to the final temperature. Okay, it means that the final temperature will be higher than the temperature of the water, since the iron nail has higher temperature. Okay, this is our first assumption. Our second assumption is the temperature of the iron nail will decrease eventually because the water had a smaller temperature. So, the final temperature will be reduced from 50 degrees Celsius. Alright, those are our assumptions. Now, let's continue. Alright then, 0.2 times 4,200 times T, so we get 440 T minus 25,200 degrees Celsius. Alright, so we calculate the same to the iron nail, and then we have here T, the final temperature, equal to 31.94 degrees Celsius. This is the final temperature. Okay, when we compare to the temperature of water, the initial temperature of water is 30 degrees Celsius. Now it had increased by 1.94 degrees Celsius, whereas the temperature of iron nail initially was 50 degrees Celsius and will drop to 31.94 degrees Celsius. Alright, now this is the final temperature for the system, since they are in thermal equilibrium. Alright, that's all for subtopic 4.2. Sorry, is it 4.2? Yes, 4.2 specific heat capacity. Till we meet again. Bye and Assalamualaikum.